matching or fill in the blank, so let's just see what you come up with. Take a look at that. Let f and g be continuous on an open interval involving c or containing c. If blank, then there exists an open interval containing c such that blank, for all in the interval, then the graph is given by blank has a vertical asymptote. Just, what do you think goes in the first? Which of these? Or what goes in here? Or maybe you want to choose this one. Okay. F and G are continuous if f of x does not equal 0 and g of c, I'm sorry, I said that wrong. If f of c does not equal 0 and g of c does equal 0, and there exists an open interval involving c such that g of c does not equal 0, so we've got the situation where we got one function is 0 and one function is not, and then if we can look at an open interval containing c such that that isn't true, then we have, and of course easy to put this in, then we have that the rational function has a vertical asymptote at x equals c. That's our theorem about vertical asymptotes. Okay. Well, let's go on and see how this will become, the terminology in here is what we've been talking about, but let's see what this looks like. Now, I realized in the last class that that may not be as evident, especially to you in the back. So let me just rewrite this. Now, my question to you is, I'm going to give you a quick poll on this, so be prepared. What's another way of writing g of x besides what you see here? Okay, so here comes the quick poll. You have a chance to answer this question. Did I save that? Yes, I did. Okay. And I don't have the ability to put it with vertical. I'll give you a hint. There we go. Okay. So you should have that. There we go. We have x times e to the 1/2 x power. You know what? I think I had a question in my mind before, and I think I now know what the correct answer is. How about that? My whole discussion on this problem is based on some ill-thought-through thought, and I think I checked it with the solution book too. Interesting. I like this. I like this. What I really wanted to talk about was these. We're going to talk about that. This is a good point to talk about. This one, these three. We got 4, 8. We've got 9 people who think like me. Kind of a scary proposition. 10 people who think like me. Okay. 11 people. Okay. We're going to look at those two answers because I really think this one person is more correct than anyone else. Very good. not the answer I was going to take, but that's still very good. Okay, so let's go back. Let's look at this and let's talk about it. Okay, let's get back to my notes. There we go. There we go. Okay, the idea is that if we have x, e, and the negative 2, I do agree, should be something like that. However, that's not what I wanted, so we're going to change the problem. What we want to have is this, and I'm going to put it in red so that I don't forget to do something. Nope. What I really want is this. You see what I did? Separate out that negative. I'll put it over here also. So that the answer should be, and we're going to work from this perspective because the other one's a non-problem. It's not something that would really come up. We really need to think about now bringing that exponent and its base across the fraction line. Nope. I just want to see if you could see it. And you did. You passed the visual test. There you go. Okay. Bring it across the fraction line, and you would then not have the negative down there. Okay. Yeah, that's a good one. I'll have to go back and check. It could be the solutions manual was wrong, and I just wasn't using my thinking either. But if we have this, now we have to look at vertical asymptotes. So we'll just cross that off because we don't want that after all. We have to look at vertical asymptotes. Now the question is, the problem we have over here is that g of c equals 0, if g of c equals 0. So let's go with that premise. Could, in this case, our g of c is the denominator. Could our denominator ever be 0? So that's the first question we have. Could e to the 2x equal 0? If it does, then we have a slight problem with this because we'd end up with a 0 denominator. But the question is, could it be 0? And this now leads us into some work with exponents. And an exponential function involving e, is e a variable or a constant? And it's about the value of 2 point, what is it, 2 point, it's a 7128 or 17. Oh boy, I'm really losing it now. 71. I'll go back and change it if it's wrong. But 712814 and so forth. Yeah. Okay. It's approximately that. So let's look at an easier problem. Let's say it's 2 to the a power. Could that ever equal 0? If I have 2 to the first power, I've got 2. If I have 2 to the 1/2 power, I've got the square root of 2. If I have 2 to the 0 power, what is 2 to the 0 power? Why? Why? You know, it's one of those things we always memorize, isn't it? Pardon? Why? Someone defined it, but why do they define it that way? Oh, you will in just 2 seconds here. Okay. The thing is, when you have, let's say, 2 squared, we have 2 times 2. And if we have 2 cubed, we have 2 times 2 times... What does the exponent tell us? The exponent tells us what? How many times we use what? The base as a what? As a multiple, a multiplier, let's say factor, okay, as a factor. So if I have 2 cubed, I know I have 3 factors of 2. If I have 2 to the 5th, I'd have 5 factors of 2. What if I have 2 to the 0? It tells me I have how many factors of 2? So why isn't the answer 0? What? Ah, that number that's multiplied to every number, right? So if I don't have any factors of 2, what's the only factor that's left? 1. And now you know the rest of the story. Okay? So now you know. You know why. It's not one of those things I just memorized and they told me it had to be that. I now know that there's a reason why. How many factors do we use of the base? We don't use any. What's the only thing that's a factor then? 1. Why? 1's a factor of everything. Okay. Now, we also get down to 2 to the negative 1. That'd be 1/2. 2 to the negative 2 is 1/4 and so forth. Is there any possibility of these outputs getting closer or getting to 0? Yeah. And if you look at the graph of that, all exponential functions have this shape to them. Whoops. That's supposed to be a continuation of that line. Okay. So we have that it has a horizontal asymptote in this direction, but it always goes infinity up there. So is it possible for this to have a 0 value? No. What was the question? Find the vertical asymptotes. Therefore, g of x has how many vertical asymptotes? It's impossible, so therefore it has no vertical asymptotes. I use VA for vertical asymptotes, so please feel free to use that also. Okay, let's see here. Yeah, we probably ran over time on this, did we? No. Okay. I want to stop real soon, but I want to look at this one problem. We're going to begin it. We're not going to end it. We have the natural log of z squared minus 4. Now, again, we need to find vertical asymptotes. And what we're going to do is we're going to ask the question, is it possible for the natural log of z squared minus 4 to be undefined? You see, by making the last problem, making that denominator 0, asking the question, could it ever equal 0? We were really asking the question, could the function ever be undefined? We want to know, is it possible for this function to ever be undefined? We'll even put z in there. If we have the not the limit, the natural log of z squared minus 4, we have to know how to interpret this. And it's a logarithm. I gave it to you once before. Logarithms can be defined by one word. What's the one word? Exponent. So it's equal to something, and that something represents an exponent. Now, I can't rewrite this and make that an exponent just floating in space. It has to be attached to what? And what's the base? For a natural log, e. Okay. And so we're saying e to what power equals what? Z squared minus 4. So we need to find out, is it possible for this function to be undefined? What would make the natural log undefined? That's what we're looking for here. Now, I'm going to stop this right now, and then we're going to come back and pick it up, because I don't have time to finish the thought on that. Wait.